Let's start. I will create a configuration file for our API settings in our Flutter application. This will help us to manage for Android and iOS platforms. I will create a new folder named config, create the API config Dart inside the config file. This file will contain the API configuration settings. We import the Dart IO and use platform to determine the operating system on which the app is running. Static const debug true for debug mode. And the static const API timeout sets the timeout duration for API requests. The Android emulator uses the access the 10.02 host machine localhost. The iOS simulator can access those machines localhost directly. In this step, we are setting up a configuration file to store essential application settings and constants. Especially, we will define the Google Client ID, which is necessary for integrating a Google sign-in functionality. Inside config file, I create a app config file, app config class, and static constant name is Google Client ID. Store our Google Out Client ID. ID is necessary for authenticating user with Google sign-in. Inside the config folder, I will create the index file. The index file, I will export both API config and app config classes. This will allow us to import all configuration settings from a single file. So we can make it easier to manage and access these settings in our application. We will use the Flutter Secure Storage package to securely store, retrieve and manage tokens. Inside the storages folder, I will create the token storage Dart file. I will define it the token storage class. Set up storage options for both iOS and Android to ensure secure and platform-specific storage mechanism. Read operation retrieve the value associated with a specific key. Delete operation remove the value associated with a specific key. And write operation is save the value with a specific key. Contains key check, verify if a specific key exists in storage. Remove the access token from storage with clear storage. It is for logout we use this function. Update token store or update the access token in storage. Get access token, retrieve the stored access token. And check access token, check if an access token is stored. I will create an API file inside the core folder. This file is central to managing all API interactions in our Flutter applications. I use the Dio package for HTTP request. I will start by importing necessary packages and configuration files. The API class is implemented as a singleton to ensure that only one instance of the API client exists throughout the application. We configure the Dio client to handle HTTP requests, including accepting base options like base URL and timeouts. Authorization interceptor adds an authentication token to the request headers if available. Logger interceptor logs requests and response details for debugging. User agent, we dynamically retrieve and set the user agent header using a package info to provide application details with each request. The handle error method manages API errors by categorizing them and throwing appropriate exceptions. Now I will create a repository folder. Inside the repository folder, I will create out repository class. This class is responsible for handling authentication related tasks in our Flutter application. This class between the API and the token storage, providing a clean and organized way to manage authentication logic. I will start importing the necessary packages and classes to manage API requests and token storage. The auth repository class encapsulates the authentication logic, making it easy to maintain and extend. Out with code method send the Google authentication code to to backend API and process the response. Try catch block handles errors and exceptions. Method to clear the stored access token for user login out. Now I will create outstate class inside the state folder. Outstate class will be responsible for managing the authentication state in our app. This class uses the change notifier to notify listeners of state changes. I will start with importing necessary packages and auth repository handle authentication logic. The outstate class is declared with the change notifier mixin, which allows it to notify listeners of changes. State variables is loading a boolean that indicates whether an authentication operation is in progress. Log out the user by clearing the access token and updating the state. As access token checks if an access token is present and updates the has access state, notify listener of changes. Out with code authenticates the user with Google code, returning the result of the authentication process. I will create a home screen class inside the screen folder. The main landing page for users who have successfully logged into the application. This screen provides basic functionality such as login out and navigating to the sign up screen. I will start by importing the necessary packages and files. The home screen class is stateless widgets, providing a simple structure for home screen. Provides the logout functionality by calling the logout method from outstate. Upon logout, it navigates the user the sign up screen. I will create a sign up class which provides a user interface for signing up or logging in with Google. The screen utilizes the Google Sign-in API and manages the authentication flow in the Flutter app. I will begin by importing the necessary packages and files, including configuration statement and the Google Sign-in package. The sign-up screen class is declared as stateful widget to manage the state of the Google sign-in process. the sign up screen. The sign up screen state class manages the state and handles user interactions. The Google login method handles the Google sign-in process, authenticating the user and navigating to home screen upon success. Error handling uses the try-catch block to handle errors during the sign-in process and provides feedback throughout the snack bar. Now I will modify the main.dart file. I will begin the importing the necessary packages and files required for our application, included state management and screens. The main function serves as the entry point of the Flutter application. This widget manages multiple providers. In this case, just outside provider, which handles authentication states. Is authenticated, the variable check if the user is authenticated. Routes defines the navigation routes for the application. Here we set up routes for sign up screen and home screen. If the user authenticated, they are directed to home screen, otherwise they are taken the sign up screen. You might encounter a certificate failed application verification failure. This error occurs because SSL TLC certificate verification issues. To bypass this verification for development purposes, we can override the default HTTP client behavior. Here is how to implement this solution. I will run the Flutter clean command to clear the build directory and remove any cached artifacts. I will execute the Flutter pub-get to install all the Dart dependencies specified in the pub-spec YAML file. I navigated to EOS EOS directory because I removed the existing some files. Then I reinstalled the pods to ensure the latest versions are used and any issues are resolved. After cleaning and updating dependencies, I run the applications on an iOS simulator to ensure everything was working as expected. I did for the app on iOS. You can follow similar steps for Android to complete the setup on your site. I hope this has been helpful in getting your Flutter project up and running smoothly. I hope you found this course helpful. If you have any questions or need further information on any part of the course, please don't hesitate to reach me out.